Preparing, clipping, and loading a cardiac slice. In this video, we'll demonstrate how to prepare a cardiac slice, how to attach the acrylic clips, and how to load a slice into the intact muscle system apparatus. First, the left ventricle must have already been removed from the animal, in this case a rat. The right ventricular free wall has been trimmed away and the septum has been cut from base to apex. To maintain viability, the solution should be kept cold and bubbled with oxygen as often as possible. A vibrotome is used for cutting the slice. Vibrotomes typically have a flat stage made of glass or metal. In this case, a glass slide 40 millimeters long and 25 millimeters wide. The blade of the vibrotome must be sharp. Here, the blade is a safety razor. A large portion of the glass slide is covered with histoacryl. The epicardial surface of the left ventricle is then dabbed onto paper to remove excess solution. The ventricle should be moist, but not dripping with solution. The epicardium is then laid flat onto the glued surface and pressed down for 20 to 40 seconds. The glue will adhere and the heart will lay flat. The endocardium will be exposed. Put fresh solution onto the tissue with a transfer pipette. As solution starts to fill the chamber, excess glue will float. Use the transfer pipette to remove the excess glue from the solution and continue to fill the chamber with fresh solution. Remember to cool the chamber and oxygenate the solution. The vibrotome has been turned on, and the blade will move slowly across the tissue while vibrating. The settings for each vibrotome and each laboratory will vary. We use an amplitude of vibration of approximately 1 millimeter peak to peak. The vibration frequency is approximately 200 Hertz, and the cutting speed is approximately 5 millimeters per minute. We've skipped ahead here about 3 minutes to the end of the first cut. The first slice is usually not usable, as it will have uneven surface of the endocardium. As the motor is retracted, the slice will be tethered to the left ventricle, and these tethers must be cut with scissors. The first slice or two may be a millimeter thick, in order to remove the irregularities of the endocardial surface. When the cut appears to expose a flat surface, as shown here, the tissue is raised 300 microns to assure that the next slice is 300 microns thick. The next 3 slices will be shown here, but sped up 4 times the original speed. You are welcome to skip ahead to the 10-minute mark. A single rat heart typically yields 4 to 8 fully intact cardiac slices. To attach the acrylic clips, there must be a well-lit area, a dissection microscope, not shown here, a glass slide, a new razor blade, a tube of histoacryl, and 2 pairs of forceps. Start by placing some solution onto the glass slide. Take a slice from the dish and place it on the slide. Gently flatten the slide onto the glass surface. Be careful not to pull on the muscle. Once flattened, use the microscope to find the primary orientation of the muscle fibers in the slice. It's useful to move the slice around and to rotate the slice to get it oriented the direction you'd prefer. In this example, the orientation is left to right. Lines left over from the cutting are running up and down, but the fiber orientation for producing force is running left to right. Using the razor blade, cut the tissue parallel and perpendicular with the orientation of the muscle fibers to produce a rectangle. The length of the rectangle running parallel with the fibers should be around 10 millimeters long, but can be between 3 to 15 millimeters long. The width of the tissue should be around 8 millimeters, but can be between 5 to 10 millimeters long. Once the rectangle has been made, put some histoacryl glue on a hard surface. In this case, we're using another razor blade. Remove excess solution from around the tissue. The tissue should be moist but not wet. Using forceps, take a clip and dip the broad end of the clip into the glue. Dab off excess glue and place the glued end onto the end of the tissue. Do the same for the other clip. Solution can then be reapplied to the tissue. After 20 to 40 seconds, push the tissue to make sure that none of the glue is adhering to the glass surface. And then return the tissue to the storage dish, making sure that it is submerged in the solution. To prepare for the next cardiac slice, use a razor blade to scrape off any glue from the glass. Solution then can be reapplied and a second slice retrieved. Clipping of another slice will be shown here, but sped up 4 times. You are welcome to skip ahead to the 18-minute, 20-second mark. To load the muscle into the chamber, make sure the instrumentation has been turned on and the hooks are closer together than the distance between the ends of the clips. Also make sure the solution in the chamber is just covering the hooks. Pick up the muscle by one of the clips using forceps and carry it to the chamber, and put the end of the other clip onto the hook attached to the length controller. Lay the tissue into the chamber to minimize the effects of surface tension. Position the second clip over the other hook attached to the force transducer. Once the tissue is in the chamber, use the manual micrometer to increase the distance between the hooks. The slice is now ready.